What's up, guys? So I'm doing another video with my Minecraft CPU. I want to talk about how I write my programs, or I guess how I've recently been writing my programs. Um, so for this computer, as I've given it a lot more instruction memory, um, I've realized that I'm going to spend a lot of time actually just programming the computer itself, so placing and breaking redstone blocks. And I've realized that in the past, I've just kind of freestyled it where I kind of have an idea of how the program works in my head, and I just try to, knowing my binary code, I just try to place redstone blocks and hope it kind of works. Um, and so I've decided that as I've, with a lot more instructions, it's going to be a lot more difficult. So I've made this Python program, a really simple program, that can translate this assembly-esque language I made into my binary for my computer. So here I'm on VS Code doing this, just for anyone who's curious. Um, but here, I'm using Python to translate this into binary. So this is a really simple program. It's for, I guess, a Fibonacci term solver, maybe. Is how I would describe it. So I give an input, which is the term of the Fibonacci sequence I want it to solve, and the computer will solve that term for me. So I'll probably go more in depth about how this works in the future when I show this off. But just know that you input the term of the Fibonacci sequence, and then it outputs what that term is. Um, so let me just kind of show you guys um, how it translates this. So it's just a really simple uh, file reader. So I like Python because or one of the things I like about Python is that it's really easy to read files. I mean, this is really all I have to do um, to break the file, to grab the file, split it by space, and append it to add it to the code list. And now I can just go through code in each line, and then line 0 is the equivalent of like byte 0, which is like the function. So here in this case it's low number, in this case it's jump, and it translates that into a binary number, and then it also um, turns the other values into the binary number and puts it in its correlating byte almost. And then when it prints it as, and remember, just the indexes start at 0. So it would print, the top right with my byte 1, which is the function, then byte 2, then byte 3, then byte 4, which is really just 0, 1, 2, 3. And it will give me my step number. So what this makes it a lot easier on me, because I can just type in the code as this like assembly-like code, and then it will automatically translate it into a binary code for me. So I can just kind of mindlessly put it into my computer without having to think about it too much. So let me show you guys it actually translating this. So as you can see here, it's printed out my steps. So in this case, we have 1. So this 1 is load, so we're loading 0 to byte 0. Here we're loading byte 1, or sorry, 1 to byte 1, and then here we're loading 2 to byte 2, which we actually see as the first 3 lines here. So we're loading number 0 to 0 byte, and here we're loading 1 to byte 1. Here we're loading 2 to byte 2, and it translates the whole thing into binary and then labels it with the steps in case I ever get confused. And so here it goes all the way to step 23, which, because it starts at 0, even though there's 24 lines here, the last step's going to be step 23. And in the last command here, we have 3 or 1, 1, which is jump, and then down here is the step we're jumping to, which is 1, 1, 0, 0, which is 12. So this translates the whole thing to binary, which makes it really easy for me when I write the programs. So all I have to do is kind of write it in this easy to read, easy to edit assembly, and then it translates it to binary. So I kind of want to show you guys what I would be doing for the CPU and for future CPUs. I've realized it makes it a lot easier to type in, the code, and it translates it for you. But yeah, so for now, that's about it. Peace.